Okay, so now we're going to move on to part B, and we're going to find inverses of graphs. We're going to talk about how the domain and range switch, and we're also going to talk about how to graph an inverse and answer some different questions. Okay, so again, I told you switching X and Y is the main step in every one of these. To define an inverse graphically, you collect the points from the original graph, then you switch your X and Y points, and then you plot the new ones. Now, something to remember about the domain and range. If you're switching your X and Y points, you're also switching your domain and range. So the domain of the inverse is the range of the original function, and the range of the inverse is the domain of the original function. Okay? And let's do some examples we're going to do some examples with domain and range first, and then we're going to do some more questions on the inverses. So first I want to, given the graph f of x, I want to graph f of inverse x. So it tells us to first collect our points. So we'll see we got 1, 2, 3, 4 points. That's good. So we collect our points, we make our table. So we're taking it a step back, whereas in the first part we were given the table and we just had to switch the points. Now you have to make your own table. So we're going to make our own table. We're going to have x and y. So this point is -7, -5. Next point is 0, -3. Next point is 3, 0. And then the last point is going to be 5, 7. So to find the inverse graph, you switch your x and y. So we're going to call this just y inverse for right now. So switch your x and y points. So all your y points come over here, and all your x points come over here. And then we're going to plot these points. -5, -7. And then -3, 0. Then 0, 3. And then 7, 5. And it's going to take the same basic shape. So looks like it's going to do something like that. Okay, my pen's a little shaky. Alright. Now, also state the domain and range for the inverse graph. So to find that, I want to show you how the inverse and the original domain and range look. Okay? So the original graph is the black graph. So the domain of the original graph, if you look, it's going to keep going left, it's going to keep going right. So that's negative infinity to positive. The range is how low does it go? Well, it's going to keep going down, and it's going to keep going up. So that's also negative infinity to positive infinity. Well, you don't even have to look at your graph once you find the original domain and range. You just switch it, and since these are both the same, you can't really tell, but the next example you will. So that turns into my range for the inverse graph, and then that turns into my domain for the inverse graph. And if you look at the graph, it matches, because as you see the blue line, it's going to keep going to the left, and it's going to keep going to the right, which is negative infinity to positive infinity. It's going to keep going down, and it's also going to keep going up, so that's also negative infinity. Excuse me, to positive infinity. Alright, the next one you're going to see a lot better. What I mean with switching, when they're both the same, it's pretty simple. So this one I also want to graph the inverse graph. So to do that, we collect our points, okay? And this one's only going to have a few. There's one right there, that's -3, -2. We've got another one right here, that's -2, -1. Got another one right here, -4, -1. We got 2 more, and I think that's all we'll need. -5, 2, running out of space, and then -1, 2. Okay, and then to do the inverse graph, let me change this to f of x. Okay, so then this is f of inverse x. And we're just going to switch the points. So all my y values from the original become my x's. And then all my x's from the original become my y's. Okay? Now we plot these points. -2, -3. -1, -2. And let's see, -1, -4. And then 2, -5. See here, see if I can move. Uh-oh. Let's see here. I can't move it, so we're actually going to be graphing on top of what I wrote. Should have thought about that. Connect your dots, and there is your inverse graph. Okay, so this is f of x. This is f of inverse x. So you can look at the domain, but I wanted to show you the graph because I want to show you that even when you don't have that graph, if you know the domain of the original graph, then you can find your inverse just by switching. So original, inverse. Okay, so the original domain here, well, quadratic keeps going left and it keeps going right. So the domain here is -infinity to +infinity. Now the range, it starts at -2 and goes up, so it's going to be bracket -2 to +infinity. Now the inverse, you just switch. The range becomes the domain, and the domain becomes the range. And to show you that it works, it says the domain starts at -2 and goes +infinity. Well, if you look, my exact values for the blue graph start at -2 and go to +infinity, so that's right. And my range, well, it's going to keep getting wider, so it also is going to -infinity to +infinity. Okay, so you just see that the domain and range is just a switch, just like your x and y. All right, here, collect points. So x, f of x. We've got the point -4, 0. Then we have the point -3, 1. And then we have the point 0, 2. And that's good enough. Now to make the inverse graph, you switch your points. Okay, so my y's become my x's, and my x's become my y's. Plot them. 0, -4. That is not, yes, that is right, sorry. 0, -4, 1, -3, and then 2, 0. I connect them. It's going to look like that, okay? Which again, your pencils are probably going to be way better than this pen. Struggling with it. There we go, you get the gist. So, to find the domain and range, so the domain of f of x, the original graph, domain is going to go from -4 to +infinity. The range, it starts at 0 and it goes all the way up. So here for the f of inverse x graph, we're just going to switch what we just wrote. That becomes the domain. This becomes my range. And if you look, it proves right. The domain is your x values. When my x values start at 0 and they get bigger, just that. My range, it starts at -4 in the y value and it keeps going up. Okay? All right. So next we're going to ask the specific questions. Okay? So there's two ways to do this. All right? So it says the graph of the function f of x equals 3x minus 4 is shown on the grid below. Which value appears to represent f of inverse x when x equals -1? So this is saying on the inverse graph, when x is -1, what is y? Okay, so we know -1 is part of the coordinate, right? So this is our original graph. We need to get some points for our inverse graph. So I'm going to collect some points from the original graph. Okay, now let's be smart about this. If when I'm switching points, one of the numbers has to be -1. So why not just collect the coordinates that have a -1 in it? So I have a coordinate right here that's a -1. That's -1, -7. And then my other -1 is right here. And it is 1, -1. Okay, you see how both of them have -1 in them? So let's see what happens when we switch these points. So I'm going to switch them to make my inverse. So it's going to be -7, -1, and then -1, 1. Well, which one of these points states that when x is -1, when x is -1, y is what? 1. Okay, so it's just like the tables, except you have to make your own table and be smart about it. If this is said when x is 2, only collect points that have a 2 in it. Okay? All right, let's do another one. The graph of a quadratic function is shown in the coordinate plane. The domain of the function is x is less than 0. So that's saying that it only took the negative side of the quadratic, because you know a quadratic does this. Well, this graph is just telling you that the domain is saying I only want the negative ones. So it's just giving you a bunch of information that is good to know, but it's not really helping us in our question, because the question is saying the function has an inverse. What is the point on the coordinate plane corresponding to f of inverse 0? So remember, inside parentheses, that's x. It's saying on the inverse graph, when x equals 0, what does y equal? So if I'm collecting points on the original graph, I need to make sure 0 is part of those points, so I don't have to collect so many points. I mean, you can collect all these points if you want to, and you'll still get the same answer. Okay, so one way is just collecting points that have whatever numbers given to you in it, or you can collect all of them and switch the table. I'm going to do it the easier way. So this has a 0 in it. That's -2, 0. I'm going to start writing f of x. And then here's another 0. That is 0, 4. Now I'm going to switch to make my inverse table. And I get 0, -2, and 4, 0. So it asked, when x is 0, what is y? -2. So -2 would be my answer. Okay? All right, so that is it for graphs of inverse. Okay, so just to sum it up, we talked about how the domain and range switches for the original graph to the inverse graph. And then when you are trying to find the inverse of a graph, you collect your points, make your f of x table, switch your points to make your inverse table, and then plot those points. Okay?